all in the right place. Let's talk about some of the announcements today. Now, home 140, we're good. Homework 0 is getting a WebAssign account. I did give a little extension until tonight because I made the deadline before I knew that there was no school. So I will have it due tonight. Homework 1 on WebAssign is due February 16th. Kind of push that back because I'm kind of rearranging when I'm going to teach certain subjects. So it's a little bit in the distance. Recorded lectures for the first 2 weeks I'm going to put on my classes. After that, just let me know if you want anything recorded. And I put some optional practice questions on my classes. If we go all the way down here, I find these practice questions on online. I don't make them myself, but I do think that they're kind of useful. They also have the answers on them if you want to check their work. Okay. By the way, is WebAssign asking you to pay?
No.
No. Okay.
Didn't make me pay.
Okay. I think the inclusive access thing might be working. I gave me a lot of grief in the beginning, so I'm glad it's actually working. Yeah. So if you're prompted to pay, just send me an email because I think a lot of my students aren't paying for it. Caitlin and what's your name? Ellen. All right. Any questions on the announcements? What we're going to do is we're going to start with basic factoring. The easiest questions that we can get are these things called quadratic expressions. Okay. And I'm going to give an example of one. Okay. This is called a quadratic. Does anyone know what it means for something to be quadratic? So why does this expression get labeled quadratic while this one isn't? X squared, good. Right, as you, if you look at this, the highest power on this polynomial is 2, right? Which means it's a quadratic expression, it's degree 2. Now, it's kind of weird when you look at the word, though. The prefix quad is on here, which typically means 4, right? So it's kind of strange why you think a polynomial with the highest degree 2 has to be quadratic. Does anyone know the reason why it's called quadratic? Okay, we have an x squared. X squared, right? And how many sides does a square have? 4, right? So that's actually why these expressions are called quadratic. The prefix for 2 isn't on here. Okay.
Only if it's x squared, so it's never like anything else to that.
You mean like 2 to the x?
Yeah.
Yeah, so this is actually an exponential expression. We'll get to that a little bit down the road, but this is not quadratic.
Oh.
Yeah. All right. I wonder if anyone knows how to factor this. Yeah.
Use the AM method. So you would need 2 terms that add up to 5 and multiply to 6.
Oh, yes, 2 terms that add up to 5 and multiply to 6. We'll get there. Let's see. What 2 terms do you think of them, Zayden?
X plus 3 and X plus 2.
X plus 3, X plus 2. So I like your method. I've actually never heard it being called the AMF method, which is cool. But let's take a look at these 2 numbers. And let's take a look at these 2 numbers. And let's try to see what these 2 have in common. Zainab already said it already, but as Zainab said, we looked for 2 numbers that added up to 5, but they multiply to make 6. Okay. So what I like to do when I look at something like this, I'm going to look at the multiples of 6 and figure out which ones add up to make 5. Okay. So multiples of 6. Yes, 1 times 6, right? And 2 times 3. And I don't think we have any more than that, right? Let me move this out of the way. Okay, so these two both multiply it to make 6, but only one of them adds up to 5, right? The 2 and the 3, which is why these guys ended up being 3 and 2. Any questions on how we factored this expression here? All right, our next example here is example 2 on your sheet. Okay. Now, yeah.
So the final answer would be the x plus 3, x plus 2.
Mhm. Yeah, so if you're asked to factor this expression, your final answer would be very good.
So why do you circle the x squared?
Oh, I circled this x squared just to say that this is a quadratic expression. So this was just how we named what this is. Yeah.
So you wouldn't break it down and make it x equals -3 and x equals -2.
Oh, okay. Yeah, so in the future, so I think next week, we're going to deal with quadratic equations,
Okay.
right? Equations have an equal sign, right? So when we have an equal sign, we're asked to solve for x. That's when we say x
Okay.
equals -3. Yeah. All right. Any other questions on this one? All right. So in general, if we see, and I'm going to leave it on the board on the side here so we can come back to it. When we see this sort of expression, x squared plus bx plus c, okay? B and c are variables. It can be any number you want. No constant in front of x squared, okay? We're looking for two numbers that add up to 5 for c and multiply c, okay? And then your final answer is literally going to be x plus the first number, x plus the next number. Okay. I want you to try example 2 on your own. There's a little difference between this one and the last example because we have signs. But I want you to take, let's say, 2 minutes, work on it, see what you can do with it. That's attached to x. Okay, so what's b in this case? -1, good. And you want it to multiply to make c, which is the constant term or the number by itself. So what's c here? -6, good. All right, let's take a look at what things multiply to make -6. Now, for multiplying two things to make a negative number, how many of those are positive? How many of those are negative? What are my two factors looking like here? One's positive and one's negative, right? Because if you multiply two negatives, they make a positive. Multiply two positive, they're still positive, right? So let's take a look at -6. Let's see, we have 1 and 6, but we could have a -1 and a -6, right? We could have 2 and 3, we could have a -2 and +3, or +2 and a -3, right? So these are all our factors we can have. The only one that seems to add up to -1 is, let's see, -3 and +2, right? So this is why Taylor wrote down x plus 2, x minus 3. Any questions on this example here?
Does it matter if I wrote first x minus 3 and x plus 2?
Yeah, it doesn't matter. So it's a good question. We could have written this. Okay. And the reason we can do that is because let's just say we have two numbers, like 2 times 3. That's the same thing as multiplying 3 times 2, right? So whenever we have multiplication of anything, we can switch them around however we want. All right. Any other questions?
So you could also do x minus 2, x plus 2.
Ooh, okay. X minus. Now, this is a little different because we changed up one of the factors, right? So this isn't the same expression, as any of these two because these two phrases don't match, right?
But don't they still add up to -1 and then multiply by 6?
Let's check. So these two numbers, -2 and +3, they multiply to make -6. Let's see if they add up. Yeah, yeah, we get +1. All right. Any other questions?
Do you always do the negative to the higher number?
No. The only reason we did that here is because we wanted them to add to -1. If we gave the negative to the smaller number, they would add to a positive number, right? Yeah. Any other questions? All right. Let's go make this a little harder. All right. We're getting to something a little bit more funky, okay? Where did I put this? That's okay, I have it on guided notes. Okay, so if we go down to tool number 6, factoring funky quadratics, we have an example. 4k squared minus 11k plus 6. This one's a little different, right? Because instead of x squared plus bx plus c, we have something in front of our highest power, right? Okay. I'm going to be honest with you. I struggled with factoring these guys when I was growing up. I think this one was like the hardest type of question whenever I saw this on my test paper. But I think I came up with a little different way on how to factor these. If you feel comfortable with factoring, a lot of people can like guess and check. I'm totally fine if you can do that really easily, but unfortunately, I can't really do it very well. Okay. What I'm going to do here is I'm going to take this 11k and split it up into 2 parts. Okay. And don't worry about how I'm splitting it up. I think you'll make more sense when I'm finished, but I'm going to take this 11k and split it up like this. Okay. So I took -11k and I said that's equal to -3k minus 8k, right? So 8 plus 3 is 11. So these two values are equal. Does that make sense? Okay, don't worry about why I did that, but I'm just gonna do that really quick. Well, now I have a polynomial that has 4 terms. What is that a sign that I need to do here? Factor by grouping. Good, good. So I'm going to group the first 2 terms and then the last 2. Okay. What do 4k squared and -3k have in common? Okay, good. Okay. If I take 4k squared and divide by k, what am I left with? 4k, good. What about -3k over k? -3, good. Let's do the other one. What do -8k and 6 have in common? 2. Anything else that I might want to do here? Might want to take out? Negative, right? Because this guy is positive. I want the first term over here to be positive as well. Okay, so I'm going to factor in -2. So what do I have to multiply by -2 to get -8k? 4. Okay, good. What about 6? -3, good. And all right, we're good, right? Because 4k minus 3, 4k minus 3 match. Okay. So what am I left with at the end? What are my 2 factors? A minus 2, 4k minus 3, good. Okay. So I kind of like this method better because I don't have to think about like, okay, like how do I split this up into like 4k minus 3, k minus 2. I have a little process to go through here. And I'm going to take you through what I did in general here. Okay. So how did I know to split up -11 into -3 and -8? What do those two numbers have in common with the other numbers up here? Yeah,
It's because if you multiply 4 and 6 together equals 24, and then -3 minus 8 equals 24, it also equals -11.
yeah, right. So I think I'm going to try to make that a little more concise, but it seems like you're saying the two numbers, -3 and -8, they add up to -11, right? But then they multiply to 24, which is 4 times 6, right? Okay. So that's kind of in general how you do these questions. You look for two numbers that add up to the middle number here, attached to the constant or the value k. And then we look for numbers that multiply to make this first number times the last number. Okay. Once we're done doing that, we can split it up like this and then factor by grouping. Any questions here? All right. In general, oh gosh, this PowerPoint did not do well this side. Okay. So let me make a little chart. Okay. X squared plus bx plus c, we just found two numbers and stuck them in here. Right? When we have ax squared plus bx plus c, okay, we have a number in front of our a. There's a few extra steps. First, we look for two numbers that add to b, right? And then we look for those numbers to also multiply to a times c. Okay. But we're not done yet, right? We have to split up bx into two parts. And then we have to factor by group. Okay, so a couple more steps, but I think it might be helpful to do it this way if you don't feel comfortable just splitting up one of these expressions in your head. Any questions? All right, so if you flip the page to the back here, example 2, I want you to try on your own. I want to try you to try using this method here. See if you can make it work. I'm actually going to have us come back together real quick. So I'm forgetting your name. Nathan. I got Nathan to write up his answer on the board. I think he did a good job of finding two numbers that added up to A and C. They added up to B, multiplied to A, C, and factored by grouping here. Let's just kind of look at what he did here. We have two numbers here. We split them up. -2 and -15. These two numbers, they add up to -17, right? And they multiply to make 6 times 5, which is also 30. I like how we split up the two numbers here. Oh, that's my special chalk. It's all good. I'll just have a tiny note. Okay, right. Then what he did is he took the first two terms, factored out a 2w, took the last two terms, factored out a -5, and we're left with 2w minus 5, 3w minus 1. Yeah.
When you back out 3,
Here? Yeah.
Yeah.
Mhm.
I know, like, going out from, like, would that be a 3 or not a 2? No, something with 2w. Would you make that a 3?
Oh, I didn't even check. Where are we?
For the 2w, is that, wouldn't that be 3 or is that 2?
The 2w. Yes. Wait, no.
No.
No,
No.
it's still,
Period
that's
two. Let me just do a little check here. I did mine in a little different way. 2W, 3W minus
three goes
1.
into six, right? And three goes into 15.
Yeah. I think this looks right.
Okay.
Yeah. If you might be confused because it doesn't really matter what order you write these two in. You could have done minus 15W minus 2 and still have gotten the right answer. I think that might be where the confusion is coming from.
You explain how we got from the second line to the third line.
Second line to the third, okay? Here's the factoring by grouping part, right? So we're gonna focus on the first two terms here, right? 6W squared and 2W have in common which number? Or
2W.
2W, right? And basically to get this first number, we're gonna take 6W squared divided out by 2, right? This gives us 3W. Does that make sense?
What if we did opposite by divided? We did 6W 2 minus 15.
16W,
That's what
can I see what you did? Okay, so we get the 15 first.
Yeah.
All right, let's break down what would happen if we did the 15 first. Because both of these are correct methods, you'll get the same answer, but you can get it in different ways. So I'm actually glad that you guys did it in different ways here. 6W minus 15W minus 2W. Okay. So what I did is I just rewrote the second line, but I switched the negative 15 and the negative 2. Okay. All right, let's factor by group. What do 6W squared and negative 15W have in common? 3.
that's what I was talking about.
Yeah, and W, right? So, okay, and what do I have to multiply by 3W to make 6W squared?
2W.
2W. What about negative 15W? Minus 5, good. Okay, and what should I factor out of 2W plus 5? Negative 1. And what I'm left with is 2W minus 5, right? Okay, finally we get 3W minus 1, 2W minus 5. Okay. So, two different methods on how to get the right answer, right? I think it's kind of cool that you can write the two factors any way that you like to.
I like the first one.
Yeah, I like that. You know what? I don't know which one I like better. Huh. You know, I kind of like the second one better, but I guess it's all up to what you like, right?
So you did two numbers and then divide by 6 and 15, we got 2, 3. Right?
Two numbers that we can divide, or that we can multiply and make 30, right?
No.
Oh, sorry.
No, right.
Yes,
Where it says 3W.
yes. Oh, what do I multiply by 3W to get 6W squared? Right, to get that 2W.
And then you got 2W. And then how do you divide?
I asked myself, what do I multiply by 3W to get negative 15W? And that was negative 5, right?
And then on the other side.
These two have to come as negative 1. So then I was like, what do I need to multiply by negative 1 to get 2W? And that was positive 2, right? And then of course the last one, what do I need to multiply by negative 1 to get positive 5? That's a negative 1.
And then on the bottom, you just,
We take these guys match, right? So I put that to here, then the outside ones I come together.
1 and negative 3, no, the negative 1 and 3 together.
And then 3W minus 1, and then the 2 that match becomes its own factor.
Oh,
Yeah. All right. Any other questions on this example? All right, I think we can have a little fun right now. I like viewing things in different ways, okay? And sometimes it's easier to get a visual explanation of things. Just to switch things up and make sure you guys are understanding everything. So let me point the Zoom camera to. Oh, I guess I can't really see. Okay. The second thing I'm going to do is move this to the dock here. Okay. All right. Now, I don't know why I'm taking off my mask. Sometimes it might be easier to understand things when we think of it in a different way, have a different perspective. A lot of you are visual learners, a lot of you are hands-on learners, and I think this might be a good way to learn factoring from a different perspective. I think it's a little. So I'll pass this out really quick. I know it's a big reach, but that's not bad. All right. Has anyone used Algebra Tiles before? All right. I actually never used one of those before, so this is why I got 1, 2, and 3. And then 1, 2. So 3. Okay. All right, so algebra tiles. What you'll see is we have one of these square ones, so they're big squares. We've got one of these rectangles, and we have these little squares, okay? So 3 types of objects here. Okay. And this is what I'm going to do. Let me move this over here. Okay, each of these represents a different thing in algebra. Okay. Okay, let's start with this big square here. Okay, what I'm going to do is label one of the sides as x. Okay, so the length of this square is x. I wonder if there's a way to focus this. That's fine. Okay. Since it's a square, what's the width of the square? X, right? Because the sides have to be the same. So let me write this on the board. Our big square. What's our area of that square? X times x, which is x squared. Good. Okay. So basically what I'm saying is this big square here represents x squared. Okay. Now let's look at this little skinny rectangle here. What's the length of this rectangle? X, right? Because it's the same length as the square. I'm going to say that the width of this rectangle is equal to 1. Okay. So in general, when we see a rectangle, what's the area of this object? 1x or just x, right? So these rectangles represent x. Okay. Finally, we have these little ones. I'm just going to say their length and width 1, which means the area is 1. And for you guys, 1. Okay. So we know what each of these means. Let's try to see if we can factor using these individual objects. Okay. Now, one thing I want to talk about is how we know that we factored something. Okay. When we see a rectangle in these objects, so let's say this rectangle here, that is something that's completely factored. And I think it'll make more sense when we actually do an example. Okay, if we have a rectangle that has something like dangling off of it, we haven't factored something. Okay. Let's look at an example. So in this example, we have x squared plus 5x plus 6. Okay, so we have one of these x squareds. We have 5 of the rectangles, right? So 1, 2, 3, 4, 5. And we have 6 of these ones, right? So 1, 2, 3, 4, 5, and 6. Okay. All right. Our goal is to make a full rectangle. Okay. Let's just try moving everything together. So got all these guys. I can kind of merge these together and we're almost at a rectangle, but I can't really stick this guy anywhere, right? Okay, so that means we have to move things around. What I like to do is move around our skinny rectangles first, okay? One thing I could do, let's just try doing this. I'm gonna take our skinny rectangles, I'm gonna keep one on the side, but I'm gonna move 4 of these to the bottom. Okay, let's see if we can complete a rectangle here. So maybe 1, 2, 3, 4, but oh man, I have 2 squares left. We can't complete our rectangle here. What else can we do? How can I split this up? Let's see. I could have 2 up top and 3 on the bottom, right? Let's try doing that. 1, 2, 3, 4. Oh, it looks like we're gonna have a complete fit here. Look at that. Okay, so what I've done is I've split up our green rectangles into 2 on top, 3 on the bottom, and then all of my 6 squares fit into the rest of the rectangle, right? All right, let's take a look at the dimensions of this rectangle. What's the width of this rectangle on top? Remember, the sides of the square are x. The sides of the rectangle are 1. So what's our width here? Okay, how long is the blue square? X. How long are these 2 rectangles? 2. So it is x plus 2 long. Does that make sense? All right, let's look at the width. Okay, how wide is this? I don't know the difference between length and width. How tall is this rectangle? X plus 3, right? So altogether, what's the area of our rectangle? Yes, x plus 2, x plus 3. And that looks like it works, right? Because we have factored our expression into 2 things that multiply to get our original expression. Make sense? All right, let's try another one. Okay. Example 2. Okay, example 2, we've got x squared minus 3x plus 2. Oh gosh, that's all the way up there. Oh no. Move down a little bit. There we go. Okay, so we've got an x squared. So I'm going to put that down. We have a negative 3x. Well, let's see. I can make a 3x using 3 of these. Any ideas on how to make it negative? Put on the red side, right? Red usually means negative, right? So let's flip them over. Okay, and then we have positive 2, so 2 of these guys, not on the red side. Okay, let's see how we can factor this. Can't do that, right? Not a complete rectangle. Any ideas on how to split up the rectangles? Yeah.
Two on the bottom, one on the side.
2 on the bottom, 1 on the side. Let's see if that works. Okay, 1, 2, look at that. We've done it, right? We've created a full rectangle, right? So how long is the rectangle?
That's,
Uh-huh,
and then this one.
yeah, x plus 1. What about how tall it is?
Would that be X plus
Oh, yeah, I like the one, sorry, I wasn't paying attention. Is that rectangle green or red?
That's red, so that would be negative, right?
Yeah, so it should actually be x minus 1, right?
Wouldn't it be X minus 2 as well?
Yes, right? So x minus 1, x minus 2. The area of our rectangle is,
X minus 1 times X minus.
yes, x minus 1 times x minus 2. Okay. Let's do one more. I meant to put something different for example 3, so that's kind of sad. Let's flip over to example 5, our last one. Okay. So this is example 5. We have x squared plus x minus 6. So we've got an x squared. We've got one of our rectangles on the positive side, and we have 6 red squares, right? 1, 2, 3, 4, 5, 6. All right. Let's see what we can do with this. 1, 2, 3, 4. Uh-oh. Can't do this, right? Because we have one of our squares left. There's really nothing we can do here, right? We can't move this rectangle down here because we have the same problem. Oh, because if we moved it down here, we still, okay, this is kind of sad. Bad example. But remember, x can be anything, okay? So this doesn't have to be length 5, right? Okay, yeah, this is a bad example. It's fine. Okay, let's just take it that we can't do this, okay? One thing we can do, okay, when we're stuck, okay? We could put 5 here, but then we can't really add that, right? There actually is a solution. There's 2 extra rules that I forgot to tell you, okay? We can always add algebra tiles as long as we do it in pairs of red and not red, okay? Why can we always add in pairs?
Because they cancel each other out.
They cancel each other out, right? This is like subtracting an x. This is like adding an x, right? So we can always add things. We can add our 1s in pairs, yellow and red. We can even add our x squares in pairs, blue and red, right? I'm gonna add a green and a red. Okay, so I'm just gonna do this. Okay. Now, last rule. I cannot do this. I can't split up my rectangles like this because I have to have all my reds together and all my greens together. Okay, so I can only split these together like this. Okay, so greens have to be on one side, red's got to be on the other side. Let's see if I can factor now. Oh, doesn't really work, right? I'm going to introduce another pair, green, red. Okay. Let's see if I can factor it now. 1, 2, 3, 4, 5, 6. Oh, look at that. I finished my rectangle, okay? So what I've done here is I've just added extra pairs of x's and negative x's to complete my rectangle. How long is my rectangle? How tall is my rectangle? X minus 2, good. Right, so in total, I have x plus 3, x minus 2. Any questions on algebra tiles? All right, example 4 is still up here. Why don't you play around with your algebra tiles? Try to see if you can rearrange the tiles to factor x squared minus 8x plus 15 together. So I've kind of brought out all of my tiles here. I got an x squared, I've got 8 of these x's, I've got 15 of these ones, right? Now let's see, how did you guys split up the x's? Yeah.
So I put 3 on the right side,
Uh-huh.
and then I put 5 on the bottom.
Yeah, right?
Yeah. And then after that, I put like 15 yellow squares. It's like all lined up together.
Yeah, so we're kind of separating everything like this, right? Oh my goodness. Shouldn't have given you such a big problem. All right, let's see how we're going. Oh, look at that. We've created a big rectangle, right? All right, looks pretty good now. How long is our rectangle?
X plus 3. Wait, no, X minus 3.
Minus 3, good. And what about how tall it is?
X minus 5.
X minus 5, right? So in total, we factored our expression, x minus 3, x minus 5. Do you see why we have to split up that last number into 2 things that multiply to that number and also add to the middle number? All right, I think it's a good explanation. Now, if you want to use these during an exam where you have to factor or a quiz, I will bring these. I don't require you to know how to use the algebra tiles, but if you want to use them during exam, totally fine, I'll bring them and you can just ask for them, okay? Any questions? All right, I think I'll let you guys out early. Have a good weekend and I'll see you on Monday.